You are running a concession stand and sold 82 hot dogs and hamburgers combined. You made $137.75 by charging $1.25 for hot dogs and $2 for hamburgers. What would your sales have been if you had increased the prices by 0.25, which is 25 cents for hot dogs and 50 cents for hamburgers? Well, hot dogs and hamburgers. So we can do this. Hot dog, we'll just make HD. That'll stand for hot dog. And then we'll have hamburgers. We'll just make that HB for hamburger. Well, HD plus HB should equal what? The number of hot dogs and the number of hamburgers added together should give me what? 137. Where do we get 137 from? I see 137.75. That's how much money was made off of them, but the question is, if I add up the number of hot dogs and hamburgers, what should that be equal to? 82. It is given right here. You are running a concession stand and sold 82 hot dogs and hamburgers. You made $137.75 by charging $1.25 for hot dogs and $2 for hamburgers. Therefore, if I have $1.25 for hot dogs, $1.25 times the number of hot dogs I have, plus $2 times the number of hamburgers I have, should equal what? 137.75. So now you have two equations that you can use to solve as a system of 2x2 equations. And we're going to be solving for the number of hot dogs and hamburgers initially. Do not multiply the top by 125 or by 2. Although by 2 might be a good idea. Usually we have to do these by substitution, where you rearrange this equation. But since we have a 2, an even 2 here, there's no reason why we can't multiply the top by 2 to get 2HD plus 2HB equals 164. And of course the bottom would still be 125HD plus 2HB equals 137.75. What operation would I have to do to these two equations in order to eliminate something? We would have to subtract. So if we subtract here, these are gone. 2 minus $1.25 leaves me with how much? 75. So 0.75 HD. And over here, 164 minus 137.75 leaves me with 26.25. So to get the number of hot dogs, I would have to divide 26.25 by 0.75. And that comes out to be 35. The number of hot dogs sold is 35. How many hot dogs and hamburgers did we sell altogether? 82. So if I had hot dogs 35 plus hamburgers and set that equal to 82, hamburgers should be equivalent to 82 minus 35. What is 82 minus 35? 47. So we sold 47 hamburgers, 35 hot dogs. Now let's go back to the problem and review what's being asked of us. What would your sales have been if you had increased the prices by 25 cents for hot dogs and 50 cents for hamburgers? So for a new price, what would be the new price of hot dogs? $1.50. Okay, so we'll come down here and put $1.50 for hot dogs. And then we're increasing the price of hamburgers by 50 cents. So what's the new price for hamburgers? $2.50. So we'll go down here and do $2.50. How many hot dogs did we sell? 35. And how many hamburgers? 47. So let's figure out what the new sales would have been. $1.50 times 35 is $52.50. And $2.50 times 47 would be $117.50. So $117.50 plus $52.50, $170 would have been what you made if you'd increased hot dogs by 25 and hamburgers by 50 in terms of cents. You own a vending machine that sells bottles of Pepsi for $1.75 and bottles of water for $1.25. Your machine sold 200 bottles in one day for sales of $275. If your machine had sold 12 more bottles of Pepsi and 15 more bottles of water, then how much money would you have made that day? The vending machine sells bottles of Pepsi for $1.75 and water for $1.25. So that we know that Pepsi is $1.75. So $1.75 times the number of Pepsi bottles sold will give me how much I would have made off of Pepsi. And I could add that to $1.25 times W. $1.25 times W would give me how much money I made off of water. If I add those two things together, my total sales were $2.75 for the day. And then we know that the machine sold 200 bottles. So Pepsi plus water would be 200. Now on this one I'll use substitution. I'll go ahead and solve for Pepsi. Pepsi is 200 minus W. And I can plug this expression in for P there in the top equation. So $1.75 times 200 minus W and then plus $1.25 W would equal 275. And that's what we need to concentrate on first. So $1.75 times 200 would give me $3.50. And then minus $1.75 W. Plus $1.25 W equals 275. Simplify like terms. We have a negative 1.75 plus $1.25. That would be a negative 0.5. Or we can just make it as negative 0.50 since we're dealing with money. But on the other side, we would have to subtract the 350 from the left. So a negative 0.50 equals 275 minus 350, which is negative 75. And there should be a W right there and there. So W equals a negative 75 divided by a negative 0.50. That comes out to be 150. 75 divided by 0.5 is 150. The negative signs cancel out. So we sold $150 or 150 bottles of water and we know that we sold altogether 200 bottles. So P plus W, that's the 150, should equal 200. How many bottles of Pepsi did I sell? 50. Okay. So we know what we sold of each, but the question is, if your machine had sold 12 more bottles of water, or no, 12 more bottles of Pepsi and 15 more bottles of water, then how much money would you have made that day? So 12 more on Pepsi and 15 more on water. 12 more on Pepsi would give me 62, and 15 more on water would give me 165. What was the price of a bottle of Pepsi? $1.75. Okay. So we'll come down here to $1.75. And then for the water, it was what, $1.25? Okay, so 62 times 175 is 108.50. And then 165 times 125, 206.25. 206.25 plus 108.50 is 314.75. I'm giving you that the sum of a two-digit number, and we're talking about a two-digit number, the sum of the digits is going to be 11. When I reverse that two-digit number, for example, if I had 17 and I reversed the digits, what number would I have? 71. So when I reverse the digits, the new number is a certain amount higher than the old one. This one is 63 higher than the old number. We have to figure out what that number was. Again, you start out with a two-digit number, and you know that the sum of the digits is 11. Now reverse those digits to come up with a new number that is 63 higher than the old number, the original number. You can guess and check these things all the way through 100 different numbers until you get the right answer, or you can get the right answer each time using this process. And that is this. If I have two digits and I add them together to get an 11, what equation could I use to represent that? X plus y equals 11 is right. But now for the other part, before you come up with something that you can use here to make a system of equations, before you get that, you have to create it elsewhere. So you have to do some thinking, and we'll do that below. If I had a two-digit number, we know that the sum is 11, but think about a two-digit number. And I'm just going to make one up off to the side here. What if I had 43? And I wanted to represent that as an equation in its truest form, as in the value of 43. What if I didn't know 4 and I didn't know 3, but I wanted to make an equation that represents its exact value? What place is this number in? The place of this number. Tens, it's in the tens place. So if I had 10 times x, that would represent the tens place. And then y is what place? What place is a 3 in? The ones. So it's just itself. There's nothing you have to multiply it by other than 1. So notice that I have 10x plus y, and that equals the original number n. What if I reversed this? What if I reversed the two digits? instead of having 10x plus y, if I reverse the digits and put the y here and the x there, my new equation would look like 10y plus x. But in this case, we have, from this problem over here, the new number is 63 higher than the old one. So over here, here is the original number, 10x plus y. That's the exact value of the number. But over here, when you reverse it, you have 10y plus x. And how much greater was that than the original number? How much greater is 10y plus x, reversing the digits, than the original number? Here's the information from the problem. 63, yes. So if this is your new number, which is 63 higher than the old one, what do I do to n to come up with an equivalent equation here, one that is balanced? What would I have to add to n, which is the old number, to make it equivalent to that? 63, yeah. Okay. Now, you want to get this one completely in terms of n, just like this one is. 10y plus x, and move the 63 over to the left. So you have this that is equivalent to n, and you have this that is equivalent to n. Anytime I have two expressions that are equivalent, what can I do to them? Not add them together. Not substitute. Not cancel. Set them equal. Yes. So 10x plus y equals 10y plus x minus 63. All right, let's move everything over. Our variables have to go over. When I move this 10y over here, I'm going to have y minus 10y. What is that? What's y minus 10y? Negative 9y. When I move this x over here to the left, I'll have 10 minus x. What's 10 minus x? Negative 9x? 9x, right. And then over here on the right, we're left with a negative 63. I can simplify this equation by dividing everything by what? 9. And be left with x minus y equals a negative 7. That is what goes back in here. X minus y equals a negative 7. And you can solve that. I'm going to subtract so that these cancel out and be left with 2y equals 18. What would y have to be? 9. Okay, if y is 9, then what is x? 2. What was the original number? 29.